Hello everybody, get ready to do lesson 7.5 part 3 today of Pre-Calculus Math. And today's lesson will have 4 points in your notebook and 44 points will go on to your classwork sheet. Part 3, operations with matrices. And today's bell work, students, teachers, determine whether the statement is true or false, justify your answer. So give your students about 5 minutes. Teachers, do this, pause your video and turn it back on in 5 minutes. Okay, hello everybody, welcome back for your solutions for today's bell work. Determine whether the statement is true or false. Justify your answer. Number 93. Two matrices can be added only when they have the same dimension. And then for 94, we have a product here. Does that equal this over here is the question for that. So, okay, for first of all 93, true, to add two matrices, corresponding entries are added. Therefore, the matrices must have the same dimension for 93. And then this one down here, you have a matrix -6, -2, 2, -6 times 4, 0, 0, -1. Does that equal when you move this around? Okay, so be sure you understand that for the product of two matrices to be defined, the number of columns of the first matrix must equal the number of rows of the second matrix. So we have columns here times rows, and they must be equal. That is, the middle two indices must be the same. What are you talking about? Middle two indices here. A diagram be coming up. The outside two indices give the dimension of the product as shown in the following diagram. So A times B here would equal AB. So which types of matrices can we multiply here? So M here will be the columns of A. No, M would be rows of A, and then P would be columns out here of B, and then N here would be columns. Rows times columns must be equal to row over here of B would be what would have to be necessary for it to be defined, for this product here to be defined. So the outside two indices give the dimension of the product. So M times P here will be the dimension of it as shown in the following diagram, and then this will make M times P here. Okay, so let's try a matrix multiplication here. With example 8, matrix multiplication, here's our two matrices here. We have a 2 rows here by 3 columns, so we have a 2 by 3. And then here we have 3 rows by 3 columns. So the way we're going to get our other matrix out here is we're going to multiply this row by this column. And then we're going to get this position here. And then this row by this column to get this position here. And then this row by this column to get this position here. So that'll give us our top row here. We're going for a 2 by 3. And then for our second row in our product, we're going to multiply this row by this column, this row by this column, and then this row by this column to get our second row. So let's see what we got here. We got a -5 here. Man, the way we got that was 1 times -2 is -2, and then 0, and then -3 would be -5. And then for 7 here, we multiply this row by this column here. So it'll be 4, 0, and then 3 would give us 7. And then for this part of our matrix, it would be this row by this column here. So it'd be 2, 0, and then -3 would be -1. So there's our first row. Now for this row here, we'll go this row by each one of these columns here. So 2 times -2 be -4, -1, and then +2 will give us -3. And then this row by this column will give us supposedly 6. So 2 times 4 would be 8, 0, and then -2 would be +6 here for this part of the matrix. And then this row by this column for this member here. So it would be 4, 0, and then +2 would be +6 here for this matrix there. Now, what we have is we have a 2 by 2 times a 2 by 2, and so our matrix will be a 2 by 2. So we'll multiply this row times this column will give us that one. And then this row by this column will give us that position. This row by this row will give us this position in our product over here. And then this row times this column will give us this position in our 2 by 2. And this is what we should come out with. So 3 and 0 will be 3. And then 3 times 0, then 4 will be 4. And then -2 will be -2 up here, and 5 would be 0, we get -2. And then for this position here, it would be -2 and then 5, so it would be 5. So that would be how we would acquire that matrix there. Okay, so moving right along here, we have a 2 by 2 here. When we multiply these two together here, we have row times column here. So 1 times -1 will be -1, 2 times 1 will be 2, and -1 will be 1 in this situation here. And then for this position over here, 1 times 2 would be 2. Then 2 times -1 would be -2. That'd be your 0 there. And then row times column again for down here. 1 times -1 is -1. 1 times 1 would be 0. And then for this position here, it'd be 1 times 2 would be 2. And then 1 times -1 would be -1. That would be +1 there. And then for D, again, we got a 3 by 3 by 3 by 1. So row times column here, we have 6 times 1 would be 6. 2 times 2 would be 4. And 0. So 6 and 4 would be 10 for our column here, 10. And then we have 3 times 1 would be 3, -2, and then 4. So we have 7 minus 2. Let's see, wait a minute here. 3, -2, 3, -2, and then -6. Okay. So that would be -6, and -2 be -8. And then +3 be -5. And then down here, 1 times 1, and then 4 times -3 be -12. And then 6 times 3 would be -18. So we'd have 1 and 8 would be 9, and -18 would be -9. So that would be how you would get this column here from multiplying this 3 by 3 by 3 by 1. E, the product AB for the following matrices is not defined. So we have a 3 by 2 here, and we have a B here, because we have 2 columns here, 3 rows and 2 columns, and over here we have 3 rows, but we have 4 columns. So our columns need to match. Let's see, we have row here times columns. and we have one more column here, then we have rows. So it's not going to be defined because of that, because we have 3 rows here and 4 columns. So that's why it will be undefined. So let's try this one now. In these exercises, find AB if possible. So we have 3 rows here and we have 3 columns. So this will work. This will work here. So for this one here, we have row times columns. It'll be 1 and then 0. So that'll be 1 there. And then we have row here times -8 times 1, -1/8 would be 1 in that position, and then row times this, and then this would be 7/2 there. So that will be how you would derive this matrix from as a product of these 2 other matrices. Here, down here, do I do that one? I do. It's all 0, 0, 0, row times column. So 0, 0, then 5 times 0, and then row 0, 0, -3 times 0, then row times column, 0, 0, then 4 times 0. So this is how we get that product from these 2 matrices there. Okay, let's go into another example now. We have example 9, matrix multiplication. So now we have a 1 by 3 by 3 by 1. This would give us a 1 by 1. And then B here. So again, how do we get that? 1 times 2, -2 would be +2. So that'd be 4. And then -3 times 1 be -3, and +4 give us a 1. And then here we have 1 column here by 1 row here. So in this one here, this yields a 3 by 3. So we have 2 times 1 would be 2. 2 times -2 would be -4. And then 2 times -3 would be -6. That would be our first row. And then for our second row, -1, +2, and then +3, and then 1, and then -2, then -3. So we can build a 3 by 3 from a 3 by 1 by a 1 by 3 here. So using this as a multiplier, a column times a row will give us a 3 by 3. Okay, so in our next guided practice here, number 17, if possible, find AB, A times B, and B times A, go back to B times A, and then C will be A squared, square A here, and then use your graphing calculator to verify your results. So number A here will be A times B. So to go with A times B, we're going to get from a column by a row here, a 3 by 1 times a 1 times 3 is what it would be. So we get 7 times 1, 7 times 1, 7 times 2 would be 14. 8 times 1, 8 times 1, 8 times 2 would be this row. And then a -1 times 1, -1 times and then 1 would be -1. Then -1 times 2 would give us this -2. So this is how we build a 3 by 3 from a 1 by 3 times, or rather a 3 by 1 times a 1 by 3. We get this here. Now a B times A, can we go back this way now? Use B as our multiplier for that. So B times A, we'd have a 1 by 3 times a 3 by 1. So when we do that, here is our B here, and then here is our A. So 1 times 7 would be 7, 1 times 8 would be 8, and then 2 times -1 would be -2. So we have a sum here. When we add that up, we get a 13 here for our B times A. And then our A squared, and A times A, what do you think that is, students? I'm going to let you do that one. And that is your practice, guided practice. And this is your independent practice, students. Page 8, 2 points here. Okay, moving into our next example here. Example 10, matrix multiplication. Use a graphing utility to find a product AB using, here's our A, it'd be a 2 by 3, and then our B here would be a 3 by 3. So when we have this product here, note that the dimension of A is 2 by 3 and the dimension of B is a 3 by 3. So the product will have a dimension of a 2 by 3. It will have a 2 by 3. Here are our rows. And then our columns, we got 3 columns here in each. And then use your matrix editor on your calculator to check your multiplication there to find a product. So we have 8, 4, 10 in our first row here. So it would be a 1 times negative 3 plus a 2 times 4 plus a 3 times 1 will give us 8. And then a 1 times 2, and then a 2 times negative 2, and then a 3 times 2 will give us a 4. And then a 1 times 1 plus a 2 times 0 plus a 3 times 3 will give us a 10 here. And then for our second row here, it'd be a 2 times negative 3 plus a negative 5 times 4 plus a 1 times 1. See, that will give us our negative 25 in this situation. And then a 2 times 2 plus a negative 5 times negative 2 plus a 1 times 2 will give us a 16. And then a 2 times 1 plus a negative 5 times 0 plus a 1 times 3 will give us a 5 in that case there. So now moving on to our example here. Use the matrix capabilities of a graphing calculator to find AB in this situation. So if possible, so we got a 3 by 3 times a 3 by 3, which we can definitely do. And when we multiply. Okay, our guided practice here. We're going to check it, or we're going to use a graphing utility to find AB if possible. So in your graphing calculator, put these in for your AB, and once you do that, for this one you should get AB equals this here, row times column here. So for example, for 70, it'd be 7 times 2 is 14, 5 times 8 is 40, that'd be 54. Then negative 4 times negative 4 would be 16. That would give you a 70. And then row times column will give you your negative 17. Then row times column will give you your 73. And then for this row here, this row times column will give you 32. This row times this column will give you 11. This row times this column will give you 6. And then for down here, for this row here, be this row times this column. Or rather, I'm sorry, this row times this column will give you 16. This row times this column will give you negative 38. And then this row times this column will give you 70. And then down here, we have three rows and 3 columns. Then here we have a 3 by 2 here. So it'll be this row times this column will give you this number. This row times this column will give you this number. This row times this column will give you this number. And then back up again, this row times this column will give you this number. This row by this column will give you this number, and then this row by this column will give you this number. So that would be the way you do it by hand, or do it with your graphing calculator. And that will give us our 7.5 part 3 pre-calculus math today. Here's my email if you need class materials, animated PowerPoint math video at AOL.com. If you need class worksheets, homework sheets, solution PowerPoints, or if you need tutoring, email me here. Thank you very much.